Hello everyone and welcome to Physics 125 Aviation Physics. I am Dr. Guangya Chen and here is my contact information. It's a pleasure to have you with us this semester and as always, go Dolphins. Today we're starting with Chapter 1, an introduction to physics and its application in aviation. I want to start by asking a question that gets into very heart of this class. When you look at a modern airliner like this one, what do you see? It's a massive piece of machinery. A Boeing Dreamlifter, for example, can have a maximal takeoff weight of over 800,000 pounds. It's a metal tube filled with hundreds of people, their luggage, and tens of thousands of gallons of fuel. And yet, somehow, this incredible machine hurdles down a runway and climbs effortlessly to a cruising altitude of 35,000 feet. How is that possible? It almost seems like magic, but it's not. The answer to this question, the thing that makes modern aviation possible, is physics. So let's start by an introduction to physics. So what is this field of study of physics? At its grandest scale, the goal of physics is to discover the fundamental laws that govern our entire universe. We study everything from the vastness of space, a field we call astrophysics, to the intricate dance of particles inside an atom, which we call atomic physics. To put it simple, physics is the study of how everything works. It's a science that explains motion, energy, and forces. It does this by observing the world, taking careful measurements, and using mathematics to build theories that not only explain what we see, but also predict what we will see. This is a famous quote from Archimedes. Give me a lever long enough and a fulcrum on which to place it, and I shall move the world. Is this physics? Absolutely. This is a perfect, though exaggerated, statement about the power of mechanical advantage and forces. At the heart of physics is the fact that it's an experimental science. We start by observing phenomena, like Galileo famously, maybe also Arcofani dropping objects from the Leaning Tower of Pisa. From this observation, we develop models, form hypotheses, and build a robust theory and laws. So, the application of physics, including motion, explain how airplanes fly or how to send a rocket to the Mars, optics, why the sky is blue, how we can transport information from one place to another place, electricity, power homes and devices, an airplane of course, and then we have astronomy, planetary and optical phenomena. So this is an introduction to physics.